Now that we looked at some basic properties of graphs, we're going to look at some more complicated ones. We're going to talk about where the graph is increasing, where it's decreasing, where it may be constant, and then some max and min values. They could be local max and min values where the graph reaches a high point over a certain small region, or an absolute max or min value where it reaches a high or low point over the entire graph. Okay, so there's many things that we can identify here in those regards. So let's take a look at some of these questions I have written up. First one says, on what intervals is f of x increasing and decreasing? Okay, so we're going to separate those two. First of all, let's look at increasing. Well, increasing just means it's going up to the right. Okay, so when you look at a graph, you can visually get an idea. If it's increasing, it's going to be going up and to the right. And we can see there's really two main regions where that occurs in this graph. On this extreme left portion, up to this point here at negative 2.5 comma 4. And then another region here from this low point to this high point, okay, sort of in the middle of the graph. So there's two regions in which that graph is increasing. And so what we want to do is identify the intervals, which would be the x values actually, the x values in which f of x is increasing. So the interval on the left here, where it's increasing, well, it would be from negative infinity, right? This graph goes indefinitely to the left, and it comes up, and it stops increasing at this, what we're going to call a local maximum in a moment, and then it starts decreasing. Okay, so it's at that point that it stops increasing. All right, so the interval in which it increases runs from negative infinity up to, well, these are x values, so it's going to be up to negative 2.5. So now the question is, do we include or exclude the endpoint? And the answer to that is that this endpoint is actually going to be included in that interval. Now, your textbook includes it, and your textbook has a very precise definition of increasing functions and decreasing functions. The definition includes an inequality over an interval, and it turns out that that point on the endpoint does satisfy the definition. Okay, and so we're going to go ahead and include that. There is also, like I said, a second interval starting here at negative 2, or I'm sorry, at positive 2. It's x value, and so it's starting at positive 2 and going to the right up until this maximum up here at, what's that, at 8, right? X value of 8. So from 2 to 8, you have another section or interval where the graph is increasing. Again, we're going to include the endpoints on these increasing and decreasing intervals. Okay, so those are the two intervals where the graph is increasing. Now let's look at the decreasing. I may have to erase some of this. For decreasing, there are again two intervals, and decreasing is where the graph is going down and to the right. Okay, down to the right. So the graph goes down to the right here on the left, kind of in the left center portion of the graph, and then on the extreme right portion of the graph. Okay, and so for decreasing, I would say, let's go ahead and erase this first answer just because I need more space there. It's going to start at negative 2.5 and go up to 2, right? 2 is the rightmost endpoint there. And then it's going to skip and start again at 8 and run to the right. So that's going to be a union with 8 to infinity. Now infinity we never include in an interval, so we always put a parenthesis there. But the other endpoints I'm going to put brackets on because I am including them. Okay, so those are my two intervals of decreasing. Next question is, list the numbers at which f of x has a local maximum. Now a local maximum, like I said a moment ago, is a point where the graph reaches its highest value over some interval of x values. Okay, it could be an interval of any size. So any size interval, if you reach a maximum in that interval, then you've achieved a local max. Okay, and so here, for the local maximum, there are two such points. This point at negative 2.5 comma 4 there's an interval around it. It doesn't matter how big you draw this interval, as long as you can draw an interval around that point on both sides in which that point is the highest, then it's the local maximum. And so here, local maximum would occur at, at negative 2.5. So that's the first one, but remember here it says list the numbers at which f of x has a local max. So those are the x values, right? And so there's a second one over here at 8 comma 6. All right, so negative 2.5 and I'm going to run out of space there, and 8. Those are the two values at which they occur. Then it says, what are the local max values? So those are the y values for those points. So what is the height for each of those points? And the height for the first one is 4, and for the second one is 6. So we could say 4 and 6 are the local max values. Okay. Now it may ask you something slightly different. Instead of asking you for the x and y values separately, you may be asked for what are the local max and min points, in which case you would put them together as an ordered pair. Okay, number 3 says repeat number 2 but for local minimums. Okay, so let's look at local minimums. Well, there's only one of them, right? The number at which the local minimum occurs is 2. The actual local min value is at negative 3. Okay, so I'm going to separate those because they answer two different questions. Okay. All right. Next question, find the absolute max and min values of f of x. So now what we're doing is we're looking at the entire graph as a whole, and we're trying to identify where the largest value, the highest value is, and where the lowest value is. Okay. So let's look at the maximum first. Well, the highest point on this graph is pretty obviously 8 comma 6, right? It's the highest point at which no other point goes beyond that. Okay, we would say that it's the highest or greatest value in the range, okay, or the point at which that occurs. And so here, 8 comma 6 is going to be my absolute max. Now, just as a note, it is possible to have multiple absolute max points. If you have multiple points reach the same height, maximum height, if I had another point that came up 6 units high, then I would include both of them. It's kind of like a tie in a race, right? You can have two winners, I guess, if you had two people come across at the exact same moment. We probably can't really have that with anymore with the way the technology can sort that out, but if you could, we would say that it would be kind of like a tie, and you would include them both. Here, minimum values, there is one absolute minimum, and it's this lowest point in the graph. Again, it would be the smallest or least value in the range. Here, that corresponds to negative 3, so the point is 2 comma negative 3. And then number 5 here, my last question, it says find the absolute max and min values on f of x, or of f of x, on a particular interval. And so what we're going to do is we're going to chop off the rest of the graph. I'm just looking at a particular closed interval and looking for the max and min on that interval. So from negative 4 to 6, well, that's an x-axis interval. So what I really want to do is sort of chop this graph off. I'll use maybe a red line here. Chop the graph off at negative 4 and at 6. And ignore everything outside of that interval. Okay, so nothing out here matters, nothing out here matters. All we're looking at is between those two vertical lines. So that chops the graph off. That gives us our interval from -4 to 6. So then we're looking for the absolute max value and min value on that interval. Well, let's go with the max first. Well, our absolute max from the original graph has been eliminated when I chop that off, that region on the right. And so now I've got to look for a new absolute maximum. Well, absolute maximums can occur on an endpoint, unlike local maximums. Remember, local max and local mins, you have to be able to find points on both sides that are lower or higher respectively. This one, with an endpoint, you can only find points on one side. So here, the absolute max can occur on an endpoint, and in this case it does occur on an endpoint. It occurs in the point at the point 6, 5, because that's up higher than this other local max over here. Okay, so the absolute max would be at 6, 5. The absolute min, well, if I look at this interval, the absolute min hasn't changed. It hasn't been taken off by restricting my domain. And so the 2, -3 is still the absolute minimum on this graph. Now, there are times where there is no absolute max or absolute min. That can occur if you had a graph that shoots up indefinitely. Say a line, right? A line that goes, something like this, goes up indefinitely. Or you may have a parabola, in which case the tails go up indefinitely. Lots of different graphs will do that. And so there is the potential that you don't have an absolute max or min on the graph, or on an interval, if that interval is an open interval and the endpoint would otherwise, how do I want to say that? If the maximum or minimum would be on an endpoint, but that endpoint's not included, then you could have a situation where there is no max or min. Also, where there might be an asymptote somewhere in between those, on that endpoint, on that interval. If there's an asymptote in the interval where the graph shoots up indefinitely, you could also have no max or min. So there's a variety of different things that you could have, different situations you could have on these graphs. And they're all still functions, but they have different features. And we're going to see a lot of those as we move throughout this course. Okay. But for right now, this gives us a pretty good understanding of some of these really important details, like increasing and decreasing regions on a graph, local maxes and mins, and absolute maxes and mins on both the entire graph and on a small interval.